All right, so let's talk about the problems that involve power rules, specifically 64 through 69. Now, I've already made a video for 69 because it's a little more involved, so I'm just going to talk about 64 through 68, and I'm going to talk in like very specific terms about 64 and then go a little faster through the other four. So 64 through 69, I'll use what are known as the exponent rules, and these are rules that you learned in Algebra 1 that you will definitely need to know coming into this year. When you multiply two things that are raised to powers that have the same base, like this, you can put those together by adding the exponents, like this, and keeping the base the same. When you divide divide things that are raised to exponents, you subtract. When you raise a power to a power, you multiply, and anything to the 0 power other than 0 is 1. So all of those are going to come into play in doing these problems. So there's a couple of basic rules to keep in mind when you're doing these problems. And we'll start with 64 to sort of give you an example. We have 2m squared times 2m to the third. Now, it's really important to understand when you're thinking about 2m squared, the only thing that's being squared there because of order of operations is the m. If the 2 were being squared as well, there'd be parentheses around the 2m to make sure that parentheses happen before exponents. But because there's no parentheses there, the 2 and the m squared are actually separate. So I like to start off by separating those so it's less confusing. And now I can multiply the things together that can be put together. So I've got a 2 and a 2 there. That will give me 4. And m squared times m cubed, those have the same base, m. They're being multiplied. So I would keep the same base and add the exponents, 2 plus 3. Now, if we look at number 65, similar process. It's r squared divided by, and I'm going to go ahead and separate the 2 and the r cubed. The 2 on the bottom doesn't simplify with anything because there's no number on top, so it's going to stay on bottom. And then I have r squared divided by r cubed. Now, that would be this rule normally. So it would be r to the negative first. Now, negative exponents we'll talk about a little bit later. I suggest when you're using this subtraction rule that you always say bigger number minus smaller number, and the result goes where the bigger number came from. So if I look at the powers here, there's an r squared and an r cubed. The cube is bigger. So we're going to do 3 minus 2, which is 1. So r the first, and that's going to go where the bigger number was, which was on the bottom. Now, whenever you're simplifying a fraction and everything goes away on top and bottom, keep in mind that's not going to be 0, that's going to be 1, because you're dividing something by like itself, and that leaves you with 1. So looking at number 66, this one has parentheses. So everything in that is being raised to the 0 power. So that one jumps directly to the 0 power rule. Anything raised to the 0 power is 1. Number 67, x squared y to the 4th all to the 5th. Now, when you raise a product to a power, like we're doing here, you can basically separate those things and raise them to powers. You cannot do that if it was adding or subtracting on the inside, and we'll talk more about that a little bit later in the year. And actually, there's a problem like that in the summer work where you can't just separate them and raise them to powers. And I've already made a video on that one, I think, but if I haven't, I can go back and do that. So what this means then is I can separate these and raise them each individually to their powers. Can do that with addition and can do that with multiplication and division, but not addition and subtraction. And then that falls under this rule. So x to the 2 to the 5th would be x to the 2 times 5, and y to the 4 to the 5th would be y to the 4 times 5. And now number 68. We got 6xy squared times negative 8x plus 9y. Again, the numbers separate from the variables because there's no parentheses grouping the numbers and the variables. Now this time we're multiplying by an addition, and anytime you're multiplying something by an addition or subtraction, that involves the distributive property. So what this means is this thing can be multiplied by this and then multiplied by this. That only happens when you're multiplying by an addition or subtraction, not a multiplication or division. So 6xy squared times negative 8x. Let's see, 6 times negative 8, x times x, and then the y squared doesn't have anything to multiply by it. And then plus, now we distribute it to the second thing. 6 times 9, x, there's nothing to multiply it by, so it stays x. And then y squared times y. You'll get more practice with these exponent rules a little bit later in the year, but it's important to have them in your mind and how they work as we get ready to get started.